Hey guys, it's Mr. C, and in this video, I'm going to show you how to solve absolute value inequalities. So like I always do, I start out with the simplest one that I can possibly find. You have the absolute value of x, and you have greater than 4. So what's going to happen here is, just like with inequalities, we're probably going to get a span of numbers that are going to satisfy this, such as 5, 6, 7, 8. Also, -5 would work, -6, -7, -8, and so on. And all the decimals and fractions and irrational numbers you can think of, they're all greater than 4. They're either greater than 4 to begin with, or when you take the absolute value, they're greater than 4. So here's how we do it. The first one, much like the equations, we remove the absolute value bars and you just solve the inequality as is. And in this case, it's done. The second one, however, is not as fortunate. You're going to remove the absolute value bars. Now, like for equations, we made this negative. However, we also saw with equations that we had to divide by -1. And so what's going to happen is, like for inequalities, because of that dividing by -1, we also have to flip that symbol for the second one. And so what happens is we get two solutions, x is greater than 4 and x is less than -4. All right, so let's see what the graph of that's going to look like. So the graph has to have those two numbers on it. We'll put -4 over here. We'll put +4 over there. And we have all numbers bigger than 4, strictly bigger than 4, and all numbers strictly less than -4. So these are going to be open circles. We want all numbers bigger than 4 and all numbers less than -4. So just as a little background, when the symbol is pointing this way to the right, we would generally call that an OR. And that's generally what ORs are going to look like for absolute value. They're going to be going like this, away from each other. And so we'll look at a variety of these just to get an idea of how these work. And so let's just go ahead and dive into it. Okay, this one, we've got two inequalities going on here. First one, 3x plus 1 less than or equal to 8. Second one, 3x plus 1, and then we have to flip the symbol, greater than or equal to, and make that negative. Two things, -8. All right, we'll solve these. -1, just like we did in our inequalities video. Less than or equal to 7. Divide by 3. And we've got a fraction here. X less than or equal to 7/3. Very common to get fractions. That's no problem. -1, -1. Bring down my 3x. Greater than or equal to -9. Divide by 3. And we get x greater than or equal to -3. So when I make my number line here for my graph, I need two numbers on there. I need -3 and I need 7/3. And I just leave it as 7/3 as an improper fraction. All right, so we have closed circles this time because we have a little equals part on there. So closed circle, closed circle. Okay, we got all x less than this guy going this way, but at the same time, all x bigger than or equal to -3 going this way. So what we end up doing is we end up shading the inside part right there. And so we generally call this an and. And ands, by looking at the graph, are going to go towards each other. And it's going to be the middle part when you have these absolute values, unless I start playing around with negatives and things like that. So in general, that's how it's going to work. All right, let's take a look at our next one. Okay, so we've got two inequalities. 2x minus 7 greater than or equal to 23. And we have 2x minus 7. Flip it. Less than or equal to. Make that negative. -23. All right, so let's take a look. +7 plus 7. 2x greater than or equal to, and that would be 30. Divide by 2. X greater than or equal to 15 for the first one. This one, add 7. So bring down the 2x, less than or equal to Okay, negative 23 plus 7 should drop me down to a negative 16. And let's go ahead and divide by 2. Divide by 2 there. X less than or equal to negative 8. All right, is that one going to be an and or an or? It's pointing to the right. And so since it's pointing to the right, that's what we call an or, which means my graph is going to be going away from each other. So let's go ahead and show that. And so we've got negative 8 over here. We've got positive 15 over here. Close circles on both of them. And we're going to be going away because we want all x greater than or equal to 15 this way, or all x less than or equal to negative 8 going this way. So we shade these in. So let's say I didn't know if that was right. Well, pick any number less than negative 8 and pick any number greater than 15, plug them in and see if they work. There is a number between, and that's 0. 0 is between these, and 0 is not shaded, so 0 shouldn't work, right? So if you plug in 0 right there, you're going to get the absolute value of negative 7, which is 7, and that's definitely not greater than or equal to 23. So this whole region in the middle, you're not going to find any numbers that satisfy that here, but you will on either side, and you can check those for yourself, no problem. All right, let's take a look and see what our next one looks like. So this time we have 4x plus 1 absolute value less than 7. So we have 4x plus 1 less than 7. And the second one, 4x plus 1 greater than negative 7. And we know that that's going to be an and because it's pointing to the left. So in class, I usually do this. All right, so solve these. Minus 1, 4x less than 6, divide by 4, and x is less than, that would reduce down to 3/2. So 3 over 2. Don't use decimals unless there's decimals in the problem, and there's not. So we're going to leave that as a fraction. All right, this one over here, minus 1. So we got 4x greater than negative 8, divide by 4, and we get x greater than negative 2. So let's go ahead and put our number line on here. And so we have negative 2 over here, 3/2 over here. All right, we're going to have open circles because it's a strict inequality. And it's an and, so it's going to be going in. So everything shaded in between. And so we see if we pick any number between negative 2 and 3/2, such as 0, it should work. And so if you plug in 0 here, you're going to get 1. Absolute value of 1 is 1, and that's definitely less than 7. So we do have the correct part shaded right there. And if you pick any numbers on the outsides that are not shaded, they should not work for that right there. All right, let's try this one. So this time I'm throwing a negative in there. With equations, this was a bad thing. But with inequalities, it's maybe not so bad. So we just need to take a look and see what's going to happen here. For our first one, we have x minus 8 greater than negative 3. Second one, we have x minus 8 less than positive 3. So I'm sticking with the plan to see what happens. All right, so I add 8, and I get x is greater than, and that would be 5. Okay, over here, I add 8 again, and I get x is less than 11. All right, now here's my number line. So it does pay to kind of check these to see what's happening when you get negatives here or a negative out front here. All right, so we got 5 here. We got 11 there. All right, now we're going to be tempted to say that that is an or, right? However, I'm going to be very careful here. I'm going to have open circles. So 5 and 11 are where they're going to start. And I'm going to start testing some numbers here to see if it works. So let's test a number over here, such as 0. 0 is the easiest one to test, and 0 would be over there somewhere, right? So let's test 0. Test 0. All right, so 0 minus 8 is equal to absolute value of negative 8, which is equal to 8. Is that greater than negative 3? And the answer is yes, it is. And so I would shade over here. Okay, let's try a number in the middle. So let's test 8. Okay, so now we're going to test 8. And you can do this with the other ones also, but the other ones are more straightforward because they don't have negatives here that kind of start to mess things up. So we have now 8 minus 8, and that would be the absolute value of 0, which is 0. Is 0 greater than negative 3? And the answer is yes. And so it turns out that everything here in the middle works. All right, so now let's test the other side. So now we have the other side. Let's test 12. Okay, so 12, and that would be, let's see, we got 12 minus 8, and that's going to be equal to 4, and that would just be 4. Is that greater than negative 3? And the answer is yes. And so this time, I'm going to plug, well, when I plugged the 4 in, it worked. And so this side looks good. And so now I'm thinking it's everything but 5 and 11, right? But what about 5 and 11? Maybe this is just kind of messed up a little so much that 5 and 11 also work. Let's test 5. I mean, we usually don't do that, right? But let's test it anyway because you got that negative sitting there. So we have 5 take away 8. That's equal to negative 3. And that would be 3 when you take the absolute value of it. So that is greater than negative 3. So really, this should be shaded through there. And let's try 11 just to see what happens. Testing 11. 11 would be 11 take away 8. That would be equal to absolute value of 3, which is also 3. And that works because that's greater than negative 3. So I'm going to have to make another graph here because that graph is a little too cluttered. So let me do that. I don't like that graph. It's got circles on there and stuff. It's confusing. So we had 5 on there. We had 11 on there. Well, it turns out that these two open circles are solutions, right? So really what happened was the whole entire line here, the whole number line worked. As if the whole number line worked, my solution set is all real numbers. Or you could write your symbol for R right there. Now let's talk about why that worked. Everything that pops out of here is going to be positive or 0. All of those numbers are greater than negative 3. There's no number you can think of for X that's not going to be greater than negative 3 because negative 3 went down below 0. And since that happened, there's not going to be any number here that's going to mess you up. So therefore, every single X value that you plug in is going to give you a result on the left side that is definitely greater than negative 3. And we tested 1, 2, 3, 4, 5 points, and they all worked. You can test as many as you want. They'll all work for that one because of the way this was structured and the way that I set it up. So let's take a look at this one. This one, on the other hand, a student's usually going to go like this. They're going to think, well, the first one, remove the absolute value bars, and we'll solve that one as is. And the second one, x minus 2, and that would be flipped, greater than or equal to, positive 2. And so the student proceeds to solve, less than or equal to 0, right? And the second one, add 2, and then they get x greater than or equal to 4. And then the student usually does this. They take their line there, they put 0 on there and 4. They say, oh, that's an and, so it's going to be in between. They put 2 closed circles on here, and they immediately shade everything in the middle. Now, I don't know about that. Let's pick a number between 0 and 4 and see if it works. Let's pick 2. 2 minus 2 is 0. 0 is definitely not less than -2 or equal to -2. That doesn't work. So that one, no. As a matter of fact, frowny face. If you pick a negative number, -1. -1 minus 2 is -3, right? And that's going to pop out as a +3. That is not less than -2. So again, that doesn't work. Pick a number bigger than 4, 5. 5 minus 2 is 3. Absolute value of 3 is 3, not less than -2. That one doesn't work. So now nothing worked. Even though it looked like something was going to, it doesn't. And why? All of this is going to be 0 or positive. It's never going to be less than a -2 ever. And so because of the structure here, the way this is set up, this is doomed. This is going to be no solution. You can either write that down for this one or put your empty set down. So those are a couple weird ones that happen whenever you get a negative over here. You'll see those on tests and quizzes. Just be advised, check your answers, plug in some numbers just to make sure before you submit that answer as the one you want. So I hope this helps. Remember to like and share. Subscribe to my channel if you're not already, and we'll see you guys later. Bye.